Dear students, welcome to our science episodes. Today we are going to continue discussing wave motion. Today we are going to discuss the law of wave propagation. And this law explains the relation between the wave velocity, its frequency, and the wavelength. It applies to all kinds of waves. The wave velocity is equal to the distance covered by the wave in a second. It's measured in meter per second. The frequency is the number of complete waves in 1 second, and it's measured in hertz. The wavelength is the distance between two consecutive points, and it's measured in meters. The equation is wave velocity equal frequency times wavelength. If we want to calculate the wave frequency, we will use this law. The frequency equal velocity divided by wavelength. If we want to calculate the wavelength, we are going to use the same law. The wavelength equal the velocity divided by frequency. And finally, if we want to calculate the wave velocity equals to the frequency times the wavelength. From this, we can find the wave velocity as the frequency times the wavelength. Now calculate the velocity of sound wave if the frequency of a guitar string is 125 Hertz and the wavelength is 272 centimeters. As we all know, the wave velocity equal frequency times wavelength. So wavelength equal 272 divided by 100, which is equal to 2.72 meters. This is, of course, to convert centimeter to meters. And then the wave velocity equal to 125 times 2.72, it will give us 340 meters per second. Calculate the wavelength of light wave if the frequency is 6 times 10 to the power 8 Hertz and the wave velocity is 3 times 10 to the power 8 meter per second. Wavelength equal wave velocity divided by the frequency. So the wavelength equal 3 times 10 to the power 8 divided by 6 times 10 to the power 8, which is equal to 0.6 meters. Now calculate the distance between the first and the third crest of water wave if its velocity is 8 meters per second and there is 20 complete waves in 5 seconds. The wave velocity equal 8 meters per second. The number of waves equal 20 waves and the time is equal to 5 seconds. The frequency equal the number of complete waves in 1 second. It's 20 divided by 5, which is equal to 4 Hertz. The wavelength equal velocity divided by frequency, which is equal to 8 divided by the 4, which is equal to 2 meters. The distance between the first and the third crest equal 2 meters times 2, which is equal to 4 meters. Now, can you predict the relation between the frequency and the wavelength of any wave? Let's see together. In fact, the wavelength equal to the velocity divided by the frequency. Therefore, in this graph, the relationship is obvious that it is inversely proportional. So wavelength and frequency are inversely proportional. This means short wavelength is accompanied by high frequency and long wavelength is accompanied by low frequency. Now the relationship between wavelength and velocity. From the equation velocity equal wavelength times frequency, we can see that they are directly proportional to each other. So whenever the velocity increases, the wavelength will increase. And When the velocity will decrease, the wavelength will decrease accordingly. What will happen to the wavelength if the frequency of the wave is doubled? The wavelength will decrease to the half. Find the wavelength in the following cases. Wave 1 velocity equal 10 meters per second, while its frequency equals to 5 Hertz. Wave 2 velocity equal 10 meters per second, while wave 2 frequency equals to 10 Hertz. This is the equation. Wavelength equal velocity divided by frequency. So wavelength 1 equal 10 divided by 5, which is equal to 2 meters, and wavelength 2 equal 10 divided by 10, which is equal to 1 meter. Can you give reason why is the speed of propagation of radio and light waves equal, although they have different frequencies? This is because both of them are electromagnetic waves, and all examples of electromagnetic waves have the same speed. Velocity equal wavelength times frequency. Multiplying the frequency and the wavelength will give a constant velocity, which is equal to 3 times 10 to the power 8 meters per second. This is the speed of light. The speed, the waves differs in different media. If I will tell you that the speed of waves will differ in different kinds of media, will you agree? Let's see together. Sound wave speed is greatest in solids and less in liquids and least in gases. So here are the 3 states of matter, different 3 media. You will find that the sound waves speed differs in these 3 different media. So can you give reason why is the speed of propagation of sound waves different in different media? This is due to the different densities of different media. What will happen to sound waves when they transfer from air to water? You will find that in air, the sound waves have 340 meters per second speed, while in water, it's 1,500 meters per second. The speed of sound waves will increase when they will transfer from air to water, because the water particles are more dense, more close to each other, which will make it easier for sound waves to transfer. Now let's compare together oscillatory motion with wave motion. In oscillatory motion, we can say that it is repeated oscillation around a point of rest through equal intervals of time, while the waves are a disturbance that propagates and transfers energy in the direction of propagation. Here, the amplitude in oscillatory motion, it's the maximum displacement achieved by an oscillating body away from its point of rest. Remember the pendulum. In waves, it is the maximum displacement achieved by the particles of the medium away from their points of rest. The frequency, it's the number of complete oscillation made by an oscillating body in 1 second. Here is the number of complete waves in 1 second. Frequency, the number of complete oscillations made by an oscillating body in 1 second, while in waves, it is the number of complete waves in 1 second. Both are measured in hertz, of course. Periodic time. In oscillatory motion, it is the time taken by an oscillating body to make 1 complete oscillation, while in waves, it's the time taken to make 1 complete wave. Velocity. It decreases as the oscillating body moves away from the rest point. In waves, it differs from one medium to another. Examples: for oscillatory motion, we have the pendulum, the tuning fork, and the spring, while in waves, mechanical longitudinal sound waves, mechanical transverse water waves, and electromagnetic transverse light waves. Now it's time for questions. Write the scientific term. A disturbance that propagates and transfers energy in the direction of propagation. It's wave motion. The number of complete waves in 1 second. Frequency. In the following diagram, identify the wavelength. It's 2 meters. Periodic time, 0.4 seconds divided by 2, which is 0.2 seconds. Frequency, 1 divided by 0.2 equal 5 Hertz. Velocity, 5 times 2 equal 10 Hertz. Frequency is proportional with periodic time, inversely proportional with periodic time. Wavelength is directly proportional with the velocity. Thank you. Dear students, thank you for watching. See you later in other science episodes.